My name is Dylan Rosenthal, and today I'll be going over proving trig identities. First, to be able to prove trig identities, you need to understand what they are. A trig identity is essentially an equality that involves trigonometric functions and is true for every value of the occurring variables where both sides of the equality are defined. So, since there are many trig identities, we use a simple tool to help remember them, known as the magic hexagon. The magic hexagon is you make the six-sided figure and you name 6 different trig functions. You would write down tangent, sine, cosine, cotangent, cosecant, and secant, with a 1 in the center. With this tool, we can find various trig identities without having to memorize them. For example, if we use the magic hexagon in this way, we can go from tangent to sine to cosine. This gives us the trig identity of tan of x equals sine of x over cosine of x. We can do this throughout the whole entire hexagon, providing us with various trig identities. We can also use the magic hexagon to find reciprocal identities. For example, if we start from one side of the magic hexagon and cut through the 1 to get to the other side, we can get the reciprocal identity of cosine, because cosine of x is equal to 1 over secant of x. And you can do the same thing all the way through. Another trig identity that we can get is the Pythagorean identities. Here you can see that there are 3 different arrows on the magic hexagon. This one goes from tangent to the 1 to secant. So this provides us with tan of x squared plus 1 squared is equal to secant of x squared. And the same thing goes for this one, where it goes sine of x squared plus cosine of x squared is equal to 1 squared. And again on this side you get 1 squared plus cotangent of x squared is equal to cosecant of x squared. So for the Pythagorean identities, you can only use these 3 arrows. You can't make your own over here, over here, or over here. You must follow it in this way. So, now that we understand the different trig identities, we can now go into proving a trig identity. It's very important that you understand the magic hexagon before you go into this. So please review the previous section if you're still confused with the magic hexagon. This is because in order to properly prove a trig identity in the most efficient way possible, the magic hexagon is the best tool to do so. So now we're going to go through how to prove a trig identity. So with these 4 simple steps, you can learn how to prove a trig identity. Step 1, when you are given the equation, you're going to want to identify which side is more complicated and which side is the simplest. Step 2 is you're going to want to write out the magic hexagon, completely labeled. Step 3, you're going to want to identify which trig identities you could use from the magic hexagon to help solve this problem and plug them in. And I would suggest that you start by using trig identities that have sine and cosine in them, just to make it easier for you. And step 4, you're going to want to simplify. So these steps, when they're not applied to a problem, seem relatively easy. But now I'm going to take you through one example problem, and then I'm going to show you how to use the various steps throughout. So the first example problem we have is cotangent of x over cosecant of x is equal to cosine of x. Now upon first glance, it seems a little intimidating. However, the purpose of this is to get cotangent of x over cosecant of x to equal cosine of x. So we are going to use the most complicated side in this equation, which would be over here. Cotangent of x over cosecant of x. As you can see, here we have it highlighted so that it is clearly defined of which side we should be focusing on. So step 2, if you remember, is to write out the magic hexagon. That's all you have to do. So you would get out a piece of paper and write out your magic hexagon right next to it. That's it. There's no tricks to this part yet. Now we get to step 3, where it gets a little bit more complicated. As I said before, you're going to want to find the different trig identities that could help you solve this. So, when you see cotangent and cosecant, you want to look for them on the magic hexagon and see where they relate to this problem. So you see cotangent goes over here, and you want to see how it could relate to sine and cosine. Well, you know that cotangent is equal to cosine over sine, and you also know that cosecant is equal to 1 over sine, and it's also equal to cotangent over cosine. So now that you have an idea of the different trig identities that you could use to help solve this problem, I'm going to show you which trig identities would be the most effective in solving this. So the two trig identities that I use to solve this equation are cotangent is equal to cosine of x over sine of x, and cosecant of x is equal to 1 over sine of x. Now, since you have these two trig identities, you're going to want to plug them into your equation, which is done over here. That's all you have to do. Plug them in, and voila, that is your new equation. So that is what you're going to want to focus on. Now that you have your different trig identities substituted into this equation, you are going to want to simplify. That is the next step. So now it looks a little bit more confusing because we've added some more elements. However, if you just focus on one side, you'll see that it's really not that complicated. All you have to do is you're going to divide cosine of x over sine of x by 1 over sine of x. And if you remember, when you are dividing with fractions, you want to do keep, change the sign to multiplication, and flip the denominator. So you're going to get cosine of x over sine of x times sine of x over 1. And as you can see, sine of x and as the denominator in the first part and the numerator in the second part cancel each other out, and you are left with cosine of x. So if you've noticed, you can tell now that cosine of x over sine of x over 1 over sine of x is actually equal to cosine of x. Therefore, you have proved that cotangent of x over cosecant of x is actually equal to cosine of x. So now that you have a taste of what it's like to prove a trig identity, I'm going to show you a bit of a more complicated problem where we're going to add an extra step. So again, you're going to want to identify the more complicated side of the equation, then write out the magic hexagon, then identify which trig identities you could use to help solve and plug them in, and you're going to want to focus on using sine and cosine, and then you're going to want to simplify. However, throughout your simplification process, you want to see if other trig identities can be used to help solve the problem. So this is when the magic hexagon is going to become extra important. So our second example problem is 1 over tan of x plus tan of x equals 1 over sine of x times cosine of x. Now, step 1, if you remember, is to identify the more complicated side of the equation. So I have identified this as 1 over tan of x plus tan of x. Step 2 is write out your magic hexagon and label it perfectly. So after you've written out your magic hexagon, you want to identify which trig identities you could use to help solve and plug them in. So if you look at tangent on its relation on the magic hexagon, you can see that how tangent is equal to 1 over cotangent, it's equal to sine over cosine, and you could use that to your advantage. However, for this equation, we're going to be using the trig identity of tan of x is equal to sine of x over cosine of x, which can be found right here. So you're just going to plug that in as usual, and you get 1 over sine of x over cosine of x plus sine of x over cosine of x. Then you're going to simplify. Now to simplify this, you're going to want to bring 1 over sine of x over cosine of x up, and you're going to want to make that cosine of x over sine of x. And that's going to simplify. You're simplifying this into cosine of x over sine of x. So again, you're going to do keep, change, flip. And then you're left with cosine of x over sine of x plus sine of x over cosine of x. And you want to make this into one fraction. So to do this, you want to have a common denominator. So you multiply sine of x by cosine of x, and same thing over here. And then you're left with cosine of x squared plus sine of x squared over sine of x times cosine of x. So now that we have this, we want to look for other trig identities that might come from the magic hexagon and help. So as you can see, we have cosine of x squared plus sine of x squared, and this is one of our Pythagorean identities, which can be found right over here. So we know that cosine of x squared plus sine of x squared is equal to 1, and we can simplify this to 1 over sine of x times cosine of x is equal to 1 over sine of x of cosine of x, and that is how we go all the way from 1 over tan of x plus tan of x to 1 over sine of x times cosine of x. So now that you have a basic understanding of proving trig identities, I'm going to review very quickly the key steps and tools to prove them. The most important tool in order to prove a trig identity is the magic hexagon. You must know this in order to properly get to your final answer. In addition, you must know the steps to prove a trig identity. Step 1 is to identify the most complicated side of the equation. Step 2 is to write out the magic hexagon. Step 3 is to identify which trig identities you could use to help solve and plug them in, and to make sure that they are in sine and cosine. And step 4 is to simplify, and step 4a is to make sure that you are looking for other trig identities that might help while referring to the magic hexagon throughout your simplification process. Thank you, and I hope you enjoyed this video. Please make sure to like, comment, and subscribe, and ask any questions in the comments below about proving trig identities that I might be able to help you with. Thank you.